Hi friends. So hope you are revising regularly whatever sums we have been doing all these days. Under the implicit functions and function of the functions, I said in the last video that we'll continue some more. Basically, a function is said to be implicit when it is not clearly given the relation between the dependent and independent variables. Whereas explicit function gives us direct link like y is equal to x square. This function can be said as explicit function because y is equal to x square. If you put x is equal to 2, for example, y is equal to 4. Straight away you get the answer. On the other hand, if I say that y is equal to xy plus log x to the power of y like that, then there is no direct relation. We have to again rearrange all y terms to one side and x terms to another side. Then only you'll be able to get a relation. So we will be converting that implicit function into explicit function and then solve the sum. So this is the difference between explicit and implicit. Explicit means it is clear. You can get a direct relation without having to do any modification of the given function. On the other hand, in the implicit function, you have to modify the sum to see that one side you'll get the dependent variable and other side only independent variable. That is called as implicit function. So today we'll work out some more sums on implicit functions and how to differentiate them. Before that, I would like to do one sum about function of a function where chain rule is employed. Okay, let us go to the whiteboard. Yeah. So now what we do, we learn something about the chain rule of certain sums so that it will be easy for us to use them in further sums. Chain rule. See here, for example, let us say I am having log sine x square. Here what happened? Log is there, operator, sine is there, operator, x square is there. So I have to do differentiation for the log. Next I have to do differentiation for the sine. Then I have to do differentiation for the x square. This is called as function of a function kind. So if let us say y is equal to this, then dy by dx will become, see how it will become now, d by dx of entire log sine x square, then d by dx of sine x square, then d by dx of x square, d by dx of x square. See, let us write here now. You know very well, d by dx of log x is 1 by x. So it will become 1 by sine x square. D by dx of sine x square, we know it very well. It is called a cos x square. D by dx of x square, 2x. So see how many functions are there here. Like log sine x square is a function, sine x square is a function, x square itself is a function. So therefore, all the three functions, they were differentiated here. The final answer is 2x cos x square divided by sine x square. Hope you are following this. Another sum I will do on this. For example, let us say I am having y is equal to root of x square plus 5x. So first what I do now, for the root I should do dy by dx. So for root of x, if it is there, we know very well it is called 1 by 2 root x. So that formula we have to call now. D by dx of inside the root what function we are having? X square plus 5x. So this becomes 1 over 2 root x square plus 5x, and d by dx of x square plus 5x is called 2x plus 5. So here 2x plus 5 divided by 2 root x square plus 5x. So you need to remember all the basic formulae. Root x formula, d by dx of root x is nothing but 1 by 2 root x. So that formula I have used here. So please remember, practice the formulas, then only it will become easy for you. d by dx of root x. Okay. So now we'll go to the straight away now implicit functions. Differentiation of implicit functions. That's what I tried to do the other day, but now we'll try to do some more. Differentiation of implicit functions. Okay, let us see. First sum. X minus y is equal to pi. This sum is looking like there is a relation between x and y, but not clearly told. X minus y is equal to pi. So far, we have seen sums of this kind. Y is equal to x square, y is equal to log. Like that clarity is there. But here, x minus y is equal to pi. So first I have to do y I have to keep here, take x that side. That is better for us. So minus y, or you take this y that side. Anything you can do. X plus x minus pi is equal to y. If you bring this pi here, x minus pi is equal to minus 5 will become plus y. Here I did what? Rearranging. So I got now y is equal to x minus pi. This means this became now explicitly clear. So now what is the differentiation? Differentiating both sides with respect to x. Then dx by dx, differentiation of x is what? Dx by dx, that is called always 1. Differentiation of pi, constant number 0. Differentiation of y, dy by dx. So therefore this is 1 dy by dx. So answer for us is dy by dx is equal to 1. This is an implicit function, it's simple sum. That's why we could do easily. Next sum we will do y plus sin y is equal to cos x. This is also implicit because here two y's are there. Y is not clearly given to us. So we have to differentiate such sums now. Let us do differentiation directly. Differentiate both sides with respect to x. Y differentiation dy by dx. Sin y differentiation, you know it, cos y. Again, function of a function for y, dy by dx. Cos y dy by dx is equal to differentiation of cos x. It is minus sin x. So differentiating both sides with respect to x, y differentiation dy by dx, sin y differentiation cos y, y differentiation again dy by dx, cos x differentiation minus sin x. So if you observe clearly here, dy by dx is common. So that I will take out common. Next page I am doing. So dy by dx, open the bracket, 1 plus cos y, correct now? See, check up. 1 plus cos y, correct. One plus cos y. This side you are having minus sin x. So therefore, dy by dx is equal to minus sin x divided by 1 plus cos y. This is the answer. So our next sum will do. Third sum on implicit side. Ax plus by cube is equal to cos y. So again, differentiating both sides with respect to x. Differentiating both sides with respect to x. So a into differentiation of x is called 1. B into y cube differentiation. Apply that formula. X to the power of n differentiation. N into x to the power of n minus 1. So 3 into y square. Y differentiation we have to do here. Dy by dx. Cos y differentiation minus sin y. Y differentiation dy by dx. Now we do one thing, we rearrange the dy by dx to one side, constant to other side. So we can retain a here or a take that side, bring this sin y here. So sin y dy by dx plus b y square dy by dx 3by square dy by dx is equal to minus a. If this a goes to that side, it becomes minus a, and this minus sin y dy by dx comes to this side and becomes plus sin y. Take out dy by dx common from both. We are left with sin y plus 3by square is equal to minus a. Therefore, dy by dx is equal to minus a divided by sin y plus 3by square. So this is the differentiation of another implicit function. So whenever we are differentiating y square, y cube like that, first we have to do for the power, then we have to do for the y alone, dy by dx. This we should not forget. In case of x square, it is 2x. X differentiation is always 1. Therefore, we are not mentioning dx by dx again and again. Dx by dx get cancelled and then you'll get x. Okay. So next another sum we'll do. Sin square y plus cos xy is equal to k. Sin square y plus cos x cos square y. This is also y only, cos square. Sin square y plus cos square. Cos xy, not cos square y. It is called cos xy. So I'm writing cos xy. Sin square y plus cos xy is equal to k. Let us differentiate this. Differentiating both sides with respect to x. So sin square y. Sin square y differentiation. First we should write for the power. So how do we do this one? 2 sin y. First for the power. Because sin square y, I will explain here for you. It is called sin y whole square. So when you are differentiating, what will happen here? 2 sin y, we should write. First for the power. Then 2 sin y whole to the power of 2 minus 1. Then for sin y, we should write cos y. Then for y, we should write dy by dx. Function of functions. So 2 sin y into cos y into y differentiation dy by dx. Okay. Here I have explained. You can see this. Sin square y, when you are getting its differentiation, is first for the power 2 into sin y whole to the power of 2 minus 1. Then sin y differentiation cos y differentiation dy by dx. All are multiplying here. Next, plus cos xy. Cos xy, cos differentiation, you know, it's minus. So minus sin xy. Then d by dx of xy is equal to k differentiation 0. So this you can write as it is 2 sin y cos y dy by dx plus into minus you write down sin xy d by dx of xy. So d by dx of xy means what? Differentiation of first function into second function plus differentiation of second function into first function, that is product rule. We will apply the product rule here, uv for xy. So I am doing that only now. So first differentiation of x, 1 into dy by dx plus 1 into 1 into y. First differentiation of x, that is 1 into second function plus first function into differentiation of the second function. Okay, please understand. First function differentiation is 1. X is called first function. Its differentiation is 1. Then y as it is you should write plus second function into first function into differentiation of the second function, that is dy by dx. So now 2 sine y cos y dy by dx minus y sin xy minus x sin y dy by dx. Just multiplication inside, minus y sin xy, then minus sin xy minus x sin xy dy by dx. Here sin xy, this is, I am writing again clearly, when you are multiplying inside sin xy, okay, when you are multiplying inside minus sin xy into y, that is differentiation of this dy by dx. Now dy by dx is common, 2 sin y cos y minus x sin xy. From this I have taken minus y sin xy is equal to 0. Therefore, dy by dx into 2 sin y cos y minus x sin xy is equal to y sin xy. Therefore, dy by dx you write down is equal to y sin xy whole thing divided by this entire thing will come underneath here. 2 sin y cos y minus x sin xy. Okay. So again, let us check this sum correctly we have done or not. Sin square y plus cos xy is equal to k. Differentiating both sides with respect to x. Sin square y differentiation 2 sin y into cos y into dy by dx plus cos xy is called minus sin xy into dy by dx of xy is equal to 0. 2 sin y cos y dy by dx minus plus into minus minus sin xy. This is uv formula we have applied. Differentiation of x is 1, 1 into y plus x into dy by dx. Then 2 sin y cos y dy by dx minus y into sin xy minus into plus minus x sin xy dy by dx is equal to 0. Then dy by dx is common between first term and the last term. Dy by dx into 2 sin y cos y minus x sin xy, correct? Minus y sin xy. Then 2 sin y cos y minus x sin xy is equal to y sin xy. Therefore, dy by dx is equal to y sin xy divided by 2 sin y cos y minus x sin xy. From trigonometry, 2 sin y cos y is called sin 2x, sin 2y. That also you can write down if you want, or retain like this, doesn't matter. Okay, for today, last sum we'll do. Sin square x plus cos square y is equal to 1. So again, differentiating, we know very well how to do. Differentiating both sides with respect to x. Then you will get 2 sines. First for the power we should do 2 sin square. So 2 sin x. This will become first 2 sin x. Sin x differentiation is called cos x. Here 2 cos square y, 2 cos y first for the power. Then cos y differentiation is minus sin y. Y differentiation is dy by dx is equal to 0. So please function of functions. First 2 sin x. Sin x differentiation cos x. Then 2 cos y. Cos y differentiation minus sin y. Dy by dx is equal to 0. So now you take out this term again. 2 sin x cos x minus 2 sin y cos y, you can write down. dy by dx is equal to 0. Take this 2 sin y cos y to that side. Retain this here. 2 sin x cos x is equal to 2 sin y cos y dy by dx. Therefore, dy by dx is equal to 2 sin x cos x divided by 2 sin y cos y. So this also you can write as sin 2x by sin 2y. Okay, this is the sum. So previously the same thing we got almost. See y sin xy divided by almost like this sum only. Slightly difference is there. Here 2 sin x cos x written sin 2x sin 2y. So friends, these are the sums based on implicit functions. So don't get confused. All will be like this only. You have to only remember the formulas strictly, and then any doubts are there, you can leave in comments. We'll be solving them. Okay. Thank you so much.